Hi everybody, this is lesson 4.2, the facts on the ground. So let's get started. Let's read the specific objectives. Students will understand that they can find formulas through the internet and reference books. A variable can be used to represent an unknown. Using a formula requires knowing what each variable represents. They must know the appropriate units for length, area, and value. Students will be able to use formulas from geometry and perform calculations that involve rates and measures to support financial decision and evaluate the expressions as well. So this lesson is a continuation of practicing with units, and we will see some of the unit analysis done here. But the focus here in this lesson will be on geometry and units. So let's look at the problem situation number 1, home improvements. Chris and Liz Sanchez have purchased a home that they want to make some improvements to it. In the following few problems, you'll calculate the cost of those improvements. You will use scale drawings of the house and lot to assist you. So here you have a picture of the house, and we have the rectangular dark border. We have the full property. Inside we got the house. The house actually here is you can see it in color since it's on the screen. It's in blue, so the house is in blue. The driveway is in gray, and the backyard is this yellow greenish kind of color. All right, so that's the backyard. So the first question is asking you, looking at this figure, all right, what does the scale that appear on the upper right corner of the drawing mean? So what does it represent? Can you write it in a sentence? I'll give you a moment. All right, so if you look at this, 1 unit, let me just use a smaller. Okay, here we go. So 1 unit represents 10 feet. All right, so each of the unit right here, each square represent 10 by 10 feet dimensions. So 10 by 10. So each of those divisions is 10. Okay, all right, so keep that in mind. And now let me keep on the screen right here the actual drawing, and then, well, I'll come back to the drawing, but let's first read this question number 2 and see what we need to calculate now. So it says the Sanchez family wants to get the backyard of the house fertilized and reseeded. They found an advertisement for Gary's Green Team Lawn Service. Gary came to the house and said that the job would take about half a day and would cost about $600. Is Gary's estimate consistent with his advertisement? All right, so here we have the advertisement. So we'll come back. Well, looking at what the costs are, so it costs for the seed 4 pounds per 1,000 square feet at $1.25 per pound. Fertilizer 50 pounds per 12,000 square feet at 50 cents per pound. And then you got 4 hours, which the labor will take. That's half of the regular workday, 4 hours. So we'll be working for 4 hours, and the cost per hour is $45. This is a little outdated in terms of the salaries and prices, but we'll use that advertisement to answer the question. So now look, this is in this lime color, you see the backyard. So they want to fertilize it and reseed it. So my question to you first, what information do we need to know about the backyard for us to start doing calculations? So here's the backyard and here's the advertisement. I'll give you a moment to decide what do we need to calculate first in order to start finding out the cost. Alrighty, so what we need to know is the area of the backyard. So we need to find the area. Okay, now you know from geometry the area equals to length multiplied by the width. So my question to you first, looking at this diagram, and you can also print out the version for you, or just look at your screen and count. What is, how are we going to approach this for the calculation? I'll try to kind of help you out as we go through this. So first, I'm asking you to find the length of this partition, okay? So can you tell me how long is this? Do not forget that you have the scale right here. So how many feet? I'll give you a moment. All right, so let's review. If you count, it's 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130 about feet, right? So here it is 130. Notice I counted by tenths because that's what the scale is about. All right, so that's that length. All right, now we got the width here. So I'll give you a moment to calculate it. All right, so let's review. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. And then you see there's like a little halfway where the border is located. So I would make that 115. About. Remember, we will estimate it as we start the calculation. But, for now, let's go ahead and get that picture. Okay, so look, the area equals to length times width. So now we're going to go ahead and notice that there's this little piece right here that's not being counted. I'll highlight it like this, just to kind of take it out so we can only look at that rectangle. So can you go ahead and calculate the area of that rectangle and also include the correct units? All right, so let's go ahead and multiply, and we get, so let's take, let me write it down, 130 feet multiplied by 115 feet. So that gives us 130 multiplied by 115. That gives us 14,950. And what are the unit? Feet multiplied by feet. We called those square feet, which makes sense. It's basically telling us how many squares of a size of 1 by 1 are there. Because when you have one dimension, let's say 1 foot, another dimension also 1 foot, like that, we call this area produced by that. Remember when we talk about population density, we also talk about the area? Same idea. So that unit is 1 square foot. And once we're multiplying, we're telling us how many of such squares are in that area. 14,950 square feet. All right, I'll give you a moment. Calculate the area of this highlighted region right here. What's the area of that? I'll give you a moment. So what would it be? All right, so the area of that small region, it's only 10 feet wide, and it is 1, 2, 3, 4, 5, so 50 feet long. So that gives us 500 additional square feet. All right, so 500 additional square feet. By the way, this is another way you can write it, 500 squared, okay? By the way, if you count this as 55, because there's a little here, a little piece, that's okay. Again, we are estimating. All right, so what would be the area, the total area? Well, we just add those two together, this and that, and we get about, what is it, 15,450 square feet, about. Okay, now moving on, we can start doing the calculation. Just because of the rounding, I would go ahead and just for our calculation, because it's better to overestimate than underestimate, because we're talking about a real kind of like a construction question. So you want to be a little bit more using a higher numbers to avoid any errors later. You don't want to go there and buy more items. It's better to have extra left, correct? So we're going to use an area at about 16,000. Okay, again, it's a big overestimate, but again, it's better more than less. Now, let's go ahead and start doing the calculations. We're going to start with the grass. All right, so let's write that down and then try. I'll give you a moment to see if you can calculate this. So 4 pounds cover 1,000 square feet. All right. And the cost is $1.25 per pound. All right. So I want to give you a moment to set this up whatever way you want it. I'm not going to ask you to do unit analysis if you don't have to, if you don't like that method, but I want you to just immerse yourself into the situation. You see the numbers, you understand the square footage, put it all together to calculate. Alrighty, so now let's review. Now you could have gotten, again, different ways. So I'm going to go ahead and use a logical way, and then we can also use unit analysis just as a way to review what we did last lesson, okay? So using logic, it says $1.25 per pound, and here it says 4 pounds, correct? Well, if you multiply those, we're going to get $6. Yes? 4 pounds, $1.25, that gives you, oh, it's $5, right? I made an error, times 4, it's $5. Okay, let's change this. It's $5, and $5 would cover 1,000 square feet, correct? Well, we have 16,000 square feet. That means we need 16 times as much area. So that means we need 16 times as much money. For every 1,000 square feet, you pay $5. So for 16,000, you're going to pay $80. So that's a logical way to answer that question. And if you did it that way, and if it makes sense to you, great, do it that way. Now, as a way of reviewing the method that we talked about in the previous lesson, we can go ahead and set it up as a unit analysis. So as a unit analysis, I'm going to write right here on top, we have money, right? It's asking how much it costs. So we're going to put $1.25 per pound. Then we put 4 pounds over how much? 1,000 square feet. The reason why I'm putting it this way is so that the pounds and pounds can cancel. And notice, look, if you multiply, it gave us the same thing, $6. I mean, again, I'm saying $5 per 1,000 square feet. The unit analysis gives us sort of similar idea. And then you multiply by 16,000 square feet because you have that land that you want to cover. So then the square footage would cancel. And then if you multiply it all together like this, you will get 80,000. You multiply it across over 1,000. The only unit remaining is $1. And then you simplify it and you get $80. Okay, so that's the unit analysis. I am not forcing you to use this method. No, no way. But I want you to see how that unit relates to the concept, right? Is that you're still getting the same result. Alrighty, guys, so now let's look at the fertilizer. So looking at the fertilizer, let's write down the summary. I mean, it's right here. I just want to save some space so I don't have to copy it. All right, but we do have 16,000 square feet. To cover. So, meaning that 50 pounds is not going to be enough. All right, because 15,000 only cover 12,000. So what are we going to do? I'll give you a moment. Alrighty, so once again, I'll show you both methods. First logic, and then we're going to talk about a unit analysis. So I'll do kind of a similar thing. If it says 50 cents per pound, and there are 50 pounds, well, then to cover 12,000 square feet, if we multiply by 50 cents, all right, because it's 50 pounds, then it would be 50 times 50 cents will be $25. exactly half, right, of 50, so $25. And $25 will cover 12,000 square feet. 12,000 square feet, correct? Well, if $25 cover 12,000 square feet, then 1,000 square feet, because if I know how much would it cost to cover 1,000 square feet, just like in the previous, question, then I'll be able to multiply by 16 and, it will give me that. Well, if $25 cover 12,000 square feet, then if you divide it by 12, that's how much will be per 1,000 square feet. So $25 divided by 12 gives us $2.08 per 1,000 square feet. I'll keep that number in a calculator. It's actually $2.08, and then there's like 333 repeating. And then we're going to go ahead and multiply it by 16 because there are 16,000 square feet. So if you multiply by 16, that will give us $33.33. All right, about. Okay, again, we estimate it. So now you can see here it's kind of harder, right, to set it up. So if you use a unit analysis for this particular question, things that can become maybe a little easier in a way. Because look, you say, okay, you're asking how much. So you put 50 cents per pound. Then you have 50 pounds for 12,000 square feet. So then the pounds can cancel. All right, and then you multiply by 16,000 square feet over 1. All right, so then you multiply it across. All right, so you multiply 0.5 times 50 times 16,000. All right, you give a really large number, 400,000, divided by 12,000. Only dollar unit is left on top. So when you divide it by 12,000, you'll get the same answer of $33.33. Okay, here it goes. Let me highlight what we got so far. $80 for the seed, $33 for the fertilizer. And the only thing we need, I think this is the easiest part compared to what we just did, and figuring the labor is just 4 hours at $45. So that would be 180. That's it. Now we can add it all together. So 180 plus 80 plus 33. So that gives us a grand total of $293.33. And Gary promised us that the cost will only be $600. Well, Gary's estimate is twice as much of what that advertisement is saying. So that is not honest, right? So here it goes. We were able to calculate this, and his estimate is not consistent with the advertisement. It should be about $300, not $600. Okay? Alrighty, let's move on. Question number 3. Chris and Liz wants to remodel their second bathroom. They go to a fake store, okay, for the purposes of this lesson, Home Deluxe, and install the top shower combo, the medium vanity, and toilet as a single unit, but decide they will tile the remaining floor space themselves. After careful consideration, they decide they like Marola tile, S&C blue, 4 inches by 4 inches each tile, at the cost of $1.98 each. All right, so that's the cost of that 4 inch by 4 inch tile, about $2. So they measure the space in their bathroom, and it is a rectangular region. So let's draw a rectangle. It will help us to model this. All right, it's 3.5 feet wide Notice I'm converting this into decimal just to make our life easier when we do calculations. And 6 1/4 feet, I guess the length. I mean, whatever you call length or the width, but these are the dimensions. Notice a quarter is 0.25. All right, so we're putting inside small tiles like this. This way, this way, this way. They decided not to glue leftover pieces. So if anything left over, they just throw it away. They're not going to glue it back together and make any cuts. So they're going to be using full tiles. And we need to figure out how many tiles should we use. All right, so here's how I'm going to ask you a question. First, we need to make sure that the units match. If you look at this tile, the tile has a dimension of 4 inches by 4 inches, while the dimension of the bathroom is in feet. So what does that mean? We need to convert feet into inches. This is a very common conversion, and I recommend to do the conversion this way. So 1 foot equals to 12 inches. So if you want to convert from feet to inches, when you go this way, you're going to multiply it by 12. So 2 feet is 24, 3 feet is 36. But if you go backwards, you're going to divide it by 12. Okay, so for example, you have 120 inches, dividing by 12 will give you 10 feet. All right, so keep that in mind, it will help you. If you go from left to right, you multiply. When you go from inches to feet, from right to left, you're going to divide. All right, so now it's easier to work with the units that are smaller. In other words, we can convert feet into inches. It's easier to multiply than to divide, converting feet into inches. So we're going to go ahead and convert. So let me ask you, what would be 3.5 feet in inches? I'll give you a moment. All right, so if you multiply by 12, you're going to get 3.5 multiplied by 12. So that is 42 inches. And this one multiplied by 12 gives you 6.25 times 12. That gives you 75 inches. All right, now an important crucial part that I would like to ask you. All right, so check this out. If you have 42 inches along the width, like that, right? There are 42. And you're putting tiles like that, where each tile is 4, 4, 4, 4, 4, and so on. My question to you, how many tiles will fit across this dimension? How many? I'll give you a moment. Well, to determine that, you just take 42 and you're dividing it by 4. That's it. So if 42 divided by 4 equals to 10.5 tiles. But since they decided not to glue anything together, they need 10 full tiles, and then the last tile, they're going to just cut in half and throw away whatever the piece remaining. So what we're going to do, we're just going to round it up to 11. Now listen guys, even if the answer ended up being like 10.3, you'll still round it to 11 because you need to use that extra tile to cut that piece from it. You understand? So that's why you need a full tile anyway. You wouldn't round it down because then you're going to have a hole left. A piece will not be tiled. So that's why we'll always round it up in that type of construction. Okay, so we have 11 tiles this way. All right, so there will be 11. Now let me ask you, how many tiles will fit along this dimension? I'll give you a moment. All right, well, this one we're also dividing it by 4 inches. So 75 divided by 4 gives us 18.75, which again, we are not going to be gluing pieces that are left, even though in this question you could have kind of used them, right? Well, actually, no, it wouldn't be enough because we only have half a tile left. So here we can round it to 18. We wouldn't have enough to, glue the rest. So anyway, 19. All right, so now the question is, let me redraw the picture so it's easier to see. All right, so we just figured out that you need 11 tiles here and you need 19 tiles there. But it's not just one row. We have, you know, like that, and then we have like that. There's a lot. This whole thing is going to be tiled, so the whole thing. So what's the total number of tiles we need? How are we going to determine that? I'll give you a moment. All right, so the total number of tiles is going to be 19 multiplied by 11. And 19 multiplied by 11 gives us 209 tiles. How much will it cost? Well, 209. This is the easier part, because we know that each of them is $1.95 per tile. So we're going to multiply this by $1.98. So that gives us $413.82. The hardest part was finding the number of tiles. And now just a little review of what it would actually cost. Well, they also need to buy adhesive, grouting, and sealant to do the job. So these supplies will add up an extra $142.14 to their bill. So we got $413.82 plus the supplies. Let me move this up. So that would be, so I'm just adding additional to the answer that I had before. Okay, so $555.96. All right, now I'm gonna give you a moment to add 7.5%. So what do we get? I'll give you a moment. All right, so we take 555.96, we multiply it by 7.5% expressed as a decimal. So that gives us an additional $41.70. And then we add this to the amount before tax. All right, and you get the grand total of $597.66. Okay, great work, guys. Alrighty, now let's look at question number 5. Now Chris and Liz want to do some painting in the house. They decide that they will paint the walls and ceiling of the living room, the walls and ceiling of the master bedroom, and the hallway and its ceiling. The living room is 10 feet by 15 feet. The master bedroom is 8 by 12 feet, and the hallway is 9 feet by 8 feet. 1 gallon of quality paint will cover 400 square feet. How much paint will be needed to do the job? Okay, so we have to break this down a little bit just to understand what is required. Notice that the paint is measured in square feet. All right, and in order for us to determine how many gallons to buy, we need to determine what? I'll give you a moment. Yes, we need to determine the entire square footage of all the area of all the walls. Okay, so we need to break this down. So we need space for that. This is definitely not enough for us to answer the question. So let me perhaps just go. Maybe let me find space. So maybe let's use this area right here to the right, and I will outline what we need. Okay, so we need to break this down. Let's start first with the living room. What are we painting? We're painting the ceiling and the walls. So if you look at this, okay, let's say this would be like a floor of the room, and then we can go ahead and find, you know, whatever area of a floor would be the same area of a ceiling. And then we got the walls there. So the question is, what would be the total space required? Okay, so maybe, you know what, let me do a better illustration. Let me do it like this. Okay, this way. and then we got this way, like I'm trying to just draw the kind of the square, the box, right, like this. Okay, and then here's another there. So this is going to be our room. So right here, the top is going to be the ceiling. All right, and then we got the 4 walls. Alrighty, so now what are the dimension of this? So the dimension of this is 10 by 15. So that would be, let's say, 15 feet long and 10 feet wide. So that means that the ceiling will also be 15 by 10. So the first question for you, I want you to calculate the area of a ceiling, which is the same as the area of a floor. What would it be? I'll give you a moment. All right, so you multiply. So the area of the ceiling would be, all right, ceiling is going to be 15 multiplied by 10. 15 feet multiplied by 10 feet. By the way, this little thing, like a prime symbol, that symbolizes the feet. And 2 dashes means an inch. All right, so it's 150 square feet. That would be the ceiling. All right, now we got the walls. Now check out the walls. The entire apartment or the house has a height of it's not mentioned right here. So I think when I was editing this, I removed one number. So the height of the ceiling, this is something that an additional information I'll provide for you. So the height of this is 8 feet. That's how high all of the walls are going to be. All right, so it's 8 feet. So here we go. So they're all 8 feet. So all of these are 8, 8, and this one is also 8. Okay, so now we got the wall. So we got, look, we got this wall, and then the one behind this. So we got 2 walls that have dimension of 15 by 8. And we have the other 2 walls, which is, let me highlight it this way, this one and the one on the back, that one, they're the same. So they are 10 by 8. All right, so what does that give us? So it's 2 walls multiplied by the area of each one. So 15 multiplied by 8, that gives us 80 plus 40, that will be 120. So it's 240 square feet. The other ones, it's 2 times 10 by 8 is 80. So it's 160 square feet. All right, and now we're gonna take that entire living room space and we can add it together. So it's 550 square feet is the total. And that's one room. Okay, so you see, study the geometry here, a ceiling and 4 walls. We're gonna do the same thing to the bedroom, master bedroom. All right, so master bedroom has a size of 8 by 12. So if we, it's kind of the same picture and the same map. So 8 by 12. I'm not gonna draw the whole thing, okay? I'm just gonna draw the floor. All right, which is 12 by 8, and the rest is the same thing. So we got the ceiling of the bedroom, which is 12 multiplied by 8. That would be 96 square feet. We have 2 walls. The height is 8, like this. There's a height. So that's 8. So it's going to be 2 times, and then it's 12 by 8. So that's 2 walls, and then another 2 times 8 by 8. So it's the other 2 walls. There are 4 walls in a room, right? It's all going to be overestimation, but still, that will give us a good approximation. All right, so it's 2 times 96, 192, 2 times 64, 128. Total is 96 plus 192 plus 128, so it's 416 square feet. I understand it's long, but the idea is you're just finding the area of everything. And area is length times width, and we add up all the dimensions. Okay, and fine, on the last room that we need is not a room, but the last thing that we need to calculate is the hallway. So the hallway is giving us to be 9 by 5. Well, 5 is a little here, and then 9 feet, so a little hallway. The hallway it's an open space, so the only thing we need to get is the area of those walls, but this will be empty because you're kind of entering this way and then you're exiting that way, so it will not have the two walls to enter. So it's just going to be the wall on the right side and the wall on the left side, but it still has a ceiling. So ceiling here is 5 by 9, which is 45 square feet. And then we have two walls along the longer side right here, which is going to be 9 by 8 because the height everywhere in the apartment in the house is going to be 8 feet. So it's two walls multiplied by 9 times 8, which is 72, and then we multiply it by 2, gives us 144. So hallway is going to be 144 plus 45, so it's 189. All right, finally, guys. I mean, I know it's a lot of calculation, but now we can go ahead and add it all together. By the way, if you ever buy paint in the Home Depot or like Lowe's, they ask you what is the size of the area of the room that you would like to paint in terms of the area footage and the floor area. So you're basically giving them this information. The area of the ceiling would be the same as the area of the room. And then they'll, okay, you need this amount, that amount. This is actually based on an average height, and they just simply do this mathematics that we're doing right here. In a computer does it, and then they tell you, okay, you need 2 gallons, 3 gallons, 4 gallons, and so on. But that's basically what the math behind it. We're doing it right now. Alrighty, so let's add this all up. 189 plus 416 plus 550. So I'm getting 1,155 square feet of area to paint. Okay, now each gallon covers 400 square feet. So can you select a choice of how many gallons to buy? I'll give you a moment. Okay, let's review. We're dividing it by 400 to see how many we need. So 1155 divided by 400 gives us 2.88. But you cannot buy, I mean, you can buy partial gallons. They sell like a little quarter, a quart, or whatever the different dimensions. But we're gonna buy just full gallons. So it looks like we just need, and in this case we always round it up, so we need 3 gallons of paint. All right, so here's the cost. It's $27.48. They also buy some supplies, and then they add the sale tax, and we get the total. I'll give you a moment to do that calculation, and then we'll be done with the lesson. All right, so let's review. So we got $27.48 per gallon multiplied by how many we need? 3 gallons. All right, so that gives us $27.48 times 3, $82.44. Add supplies. $94.41, and then the tax. I'm gonna use the shortcut from like lesson 3 or 2 at the beginning of the curriculum. I'm just gonna multiply it by 1.075. If you still remember where does the 1 come from, great work. If not, go back and review that lesson. I'll do the long way. But the answer should be $101.49. Just a little bit of warning, the numbers here were from the year 2015, 2016, so they somewhat outdated. The prices have gone up. We are in 2021 at the time of the recording of this video. Okay, that's it. We're done with the lesson.